All right, guys, so starting on number 3, make sure you have that page in front of you, okay? All right, guys, so first one here, cosecant. What is cosecant related to? Sine. Okay, so we are going to start by graphing the parent graph of sine. Okay? So, labeling the x-axis, you should know how to do that for sine. You've got pi over 2, pi, 3 pi over 2, and 2 pi. Do the negatives. And vertically, I'm going to do every 2 tick marks is 1, just because otherwise it's really smushed together. And then in red, I'm going to go ahead and graph sine. As if you can graph sine and cosine, you can graph secant and cosecant. Okay? Yeah, go ahead and connect it. Yeah, actually draw the sine graph. Okay, I'm going to switch to blue then to actually make this cosecant. Should we have sine first? All right, so you guys know cosecant is just the reciprocal of sine, right? Okay, so let's look at a couple of points here. You guys see where sine is equal to 1? Like those 2 dots that are at the 1s. What's the reciprocal of 1? Not a trick question, guys. What's the reciprocal of 1? 1. So they actually share these points. Okay, those overlap. And then what about negative 1? What's the reciprocal of negative 1? Still negative 1, right? Okay, so they share these points. Yes. Anybody need pens? Okay, now a couple other things that are important to think about. The other dots that we graphed from sine were at 0, right? What is the reciprocal of 0? Not 0. Undefined. What graphically shows us undefined? Like that. Yeah, an asymptote, right? Okay. So, at all of these points where sine was 0, and do you notice those are all the midline points? We've talked about midline before, right? That's my midline. So that's not an asymptote, that's just the midline. You are going to create a vertical asymptote at every one of those midline points. I keep saying midline because it matters. If you shift off of the x-axis, it's still the midline that causes the asymptotes, okay? So just be aware of that. Okay, doesn't look like much of a shape yet since we just have 4 dots. You don't really have to plot other dots though. You can just sketch the shape from here. If you think about some of the other values, like when you flip 1/2, it becomes 2. They all become values bigger than 1 or, bigger than -1 in the other direction. So the shape that happens is a bunch of little parabola-looking shapes. So from the top, you have a parabola going up. And from the bottom, you have that little U shape going down. paragraph. It is perfectly fine to have the sign graph drawn in on these, okay? And then just tell me like, hey, cosecant's in blue or whatever color you have, okay? So I know that you know the final answer. Does that make sense? Okay. You guys try secant. And then we'll go back and deal with domain and range. So secant is related to cosine, right? So start by graphing cosine. So guys, the process very similar to what you did for cosecant. The midline gives you asymptotes. From the top, you go up. So you kind of get little half ones on the end. From the bottom, you go down. Okay? You get like little halfsies on the end. Yeah. Okay. Questions on the two paragraphs? Do you guys agree that if you know sine and cosine, you can do those? Yeah, not that bad. Okay, domain and range. Clearly not all real numbers for the domain now, right? Okay, domain takes up a little space just because of the notation, so I'm going to do it down below here. So domain of this one. Okay, we have notation we have to do. All right, weird squiggly bracket, x. Vertical line means such that x is an element, weird e, of the reals, comma, but x cannot equal. All right, guys, where is an asymptote? 2 pi, where else? Pi, where else? 0, okay. Could I list all of them? Because it goes forever, right? So that would be, you would just be doing nothing other than that for the rest of your life. That sounds terrible. So let's not do that. So you pick one. I usually pick the one that's at 0 if it exists. You don't have to. You could start with pi or 2 pi, wherever they are. But you pick an asymptote, and then we're going to say plus or minus how far apart are the asymptotes. How far is it from one to the next? It's pi, right? So we're going to say plus or minus pi times k. All right. The k just represents integers. So that means plus or minus 1 pi, 2 pi, 3 pi, 4 pi. So you start with the one asymptote, and then it's telling you how far until the next one, and that it's just going to keep going forever. You need the k in there so that you understand there's an infinite number of asymptotes. Tanner, did I cover what? Okay. All right. Questions on that? I know the notation's weird, but do you understand where it comes from? An asymptote and then how far apart they are. Okay. All right, the range, I'll write it down here too. You can probably squeeze it in up above. We're back to just normal interval notation for that. So what's the lowest this graph goes? Negative infinity, right? Arrow's going down. And then it comes up to -1, right? Remember, we're only doing the blue. Is that going to have a bracket or a parenthesis? Bracket. Union. We start again at 1 and go to infinity. Okay, so there's your domain and range. So it's everything other than the sine graph. Yeah, Katie. The like weird E, that stands for element. It's just like that. Okay? You're going to see it over and over and over, so I think you'll just do it by the end. All right, guys, so let's try domain and range for secant. All right, so domain, squiggly bracket. It's called set notation. X such that X is an element of the reals, but X cannot equal. Okay, it's different things this time, right? Pi over 2, good. Plus or minus, how far apart are the asymptotes? What'd you say? Yeah, they're still pi apart, right? From pi over 2 to 3 pi over 2 is still pi. So it's still plus or minus pi k. Weird, but not that hard. What about the range on secant? The same, yeah. Negative infinity to -1, bracket. Okay. Question. When you're ready, turn the page back to the other side, I think. Put it backwards in your packet. All right, is this what your page looks like? All right, 5 and 6, tangent and cotangent. We're not doing those right now. We'll jump down and do number 7. All right, it's a cosecant graph. So, what is cosecant related to? Sine. So you are going to first completely graph this as if it is y equals sine of x minus pi over 2. So whenever there's an a value, a change in period, a shift, anything like that, do everything as if it's sine or cosine first. Sketch that final graph. Then your very last step is to turn that graph into secant or cosecant. So you do not need to go through graphing this as a cosecant and then shifting a it gets so messy, shifting asymptotes, things like that. Do it as sine, and then try to turn it into cosecant. You guys want to try this one? You can do it. At least get the sine graph down, and then if you're scared about how to turn it into cosecant, we'll do that together, okay? There's not a period change on this one, so it's the normal labels. John, are you labeling your x-axis?
Not yet.
Look at it. So first, I'm doing my parent graph dots in red. I need more colors. All right, where am I shifting this one? To the right by one slot, which is right by pi over 2, correct? So going over 1. connect those if you want to. And then I'll switch to blue for my final answer here. To turn it into cosecant, midline dots give me asymptotes. From the bottom, I go down. From the top, I go up. All right, how do we do on the graph? It's just sine or cosine and then one more step, okay? All right, did you write the domain? Yes, okay, let's see how we did with domain. X such that X is an element of the reals, but X cannot equal pi over 2 plus or minus pi k. Yes, okay, good. Range, same thing, it's been, I don't know why I gave you such teeny tiny blanks for domain. Negative infinity to negative 1, and then 1 to infinity. Okay. All right, how are we feeling about that? Okay. Let's do number 8, but I want to change it because the 1.5 is annoying. Let's just make it 2 secant of 2x. Okay? So you are going to graph it as if it is y equals 2 cosine of 2x. Okay? What does the 2 out in front do? Okay, so it's stretching it vertically. What does the 2 by the x do? Changes the period. So make sure you relabel that x-axis. I'll give you a minute to track. right, guys, are we okay with the period being pi? Are you starting to just kind of know the labels? A little bit, some of them? Okay. Pi over 4, pi over 2, 3 pi over 4, and pi. All right, so parent graph stretched by 2. And it's completely up to you. If you want to connect your cosine graph, like draw that curve, great. If you don't, great. I don't care. Doesn't matter. All that matters is that your final graph, you have the asymptotes. They go through those midline points. From the top, you go up. From the bottom, you go down. Give you a second to check that. You do okay? All right, domain. What'd you write for domain? X such that X is an element of the reals, but X cannot equal. That's the same.
Pi over 4.
Yes? Plus
Minus pi over 2x.
Ooh, look at you guys. On fire. Okay. What about the range this time? It's a little different too. Yeah. Where I'm going to write those. Negative infinity to negative 2. And then where? 2 to infinity. Yes? Okay, guys, one more. I'm changing number 10 too, because I want to make sure you see a shift off of the x-axis. So, number 10. Let's change this to, we just won't have a stretch. And we're going to do minus 2. Okay? So you need to graph this first as if it is y equals cosine of 2x minus pi minus 2. What do you have to do first? Factor. So I'm taking a 2 out, and that'll make it x minus pi over 2. Okay?
I was reading the thing.
You know I'm recording you, right? I figure if I can hear you, this can hear you.
Someone will think it's funny.
That's true. You will entertain someone, I'm sure. When you're ready, guys, I've graphed the cosine version of it up here. And I want to see if you can turn that into secant. Think about where the asymptotes actually come from, okay? First, make sure you're okay with the coconut crab, though. If not, let me know. Where do the asymptotes come from? Do they come from the minimum, maximum, or midline? Midline, right. Okay, they're from the midline. So, any midline point. The bottom of it. So, same idea. The x-axis. Oh, yeah, I should mention that one. I think because the ship is
But I have to. It's supposed to be OLE, so let's so like what
March is actually good. We actually put effort on it.
my work. When you what? Stand up.
Yep. I'm okay with it. Alright, let me put the final one up here. So guys, the midline, that's where the asymptotes come from. So there are your asymptotes. From the bottom, go down. From the top, go up. Okay? Getting it? Domain is X. Such that X, guys, I need you for like 1 more minute. I'm into the reels. X cannot equal, this time it's pi over 4 plus or minus pi over 2k. Yes? Okay, range, negative infinity to negative 3. And then negative 1 to infinity. Alright guys, so your homework is the actual homework page. It says homework standard 17 and 18. So, do you think you should do the graphs that are tangent and cotangent?
No.
No, so only do the ones that are secant and cosecant. I think it's only like 4 of them. And guys, if you don't like shifting by less than 1 tick mark, number 7 on the homework. Change it to just x minus pi. Okay, just cross out the 4. You guys see it? Okay. So you only have 4 questions to do for homework. Number 2, 3, 7, and 8. All right? Yes.